You know, when you think about it, the universe is kind of like this unimaginably vast crime scene. It's just full of these incredible mysteries that we've been trying to solve for, well, forever. From the most distant galaxies all the way down to the tiniest particles, we're all driven by one huge question. So, how do we actually make sense of it all? How do we take all that wonder, all that complexity, and turn it into real understanding? It's really the ultimate detective story. And that's exactly what we're going to break down here. How we investigate the cosmos, from the basic methods all the way to our most cutting-edge tools. All right, so to crack a case this big, every good detective needs a solid, reliable method, right? Well, for us, that method is science. You can think of it as the framework we use to piece together all the clues the universe leaves behind for us. So let's really get into it. At its core, science is a process. It's not just some big book of facts you have to memorize. No, it's this really dynamic way of building knowledge. And it all boils down to three key things: observing what's going on, experimenting to see if our ideas hold up, and then analyzing what we find to build an even clearer picture. And of course, the puzzle of the universe is it's way too big for just one approach. That's why we have all these different fields of science, right? Biology, chemistry, physics. But what's super exciting is how they're all starting to overlap. The really big mysteries, they almost always show up right at that intersection between fields. Okay, we need to clear something up real quick. A super common mix-up. In everyday chat, you might say, "I have a theory," when you just mean you have a hunch. But in science, it's pretty much the opposite. A scientific theory is a powerful explanation for why something happens, and it's backed by a ton of evidence. A law, on the other hand, just describes what happens. It predicts an outcome, a lot of times with a nice, neat math formula. So remember, theory is the why, law is the what. So we've got our method down. Now it's time to open up the detective's toolkit and look at the actual techniques we use to get the job done. This right here, this is basically the game plan for any scientific investigation. It always starts with a question. Then you make a prediction you can actually test. After that, you investigate to get the evidence, you analyze what you found, and, this part is key, you share your findings with everyone else. It's this powerful cycle that just keeps going. But how do we actually gather those clues accurately? I mean, our senses are incredible, but let's be honest, they can be fooled pretty easily. Is that water actually hotter, or does it just feel hotter? See? That's where scientific instruments come in. They take all the guesswork out of it. They give us objective, reliable, precise data. You know, the good stuff, the hard evidence we really need. And our instruments have totally evolved over time. Think about it. An old analog clock shows you time flowing continuously, which is cool. But a digital clock? It gives you a super specific numerical readout. And for a lot of the investigations we do today, that digital precision is absolutely crucial for getting the high-quality evidence we need. Now, when we run an experiment, it has to be a fair test. That's a golden rule. And that's where variables come in. The independent variable is the one thing you decide to change. Say, how much sunlight a plant gets. The dependent variable is the thing you measure to see what happens. In this case, how tall the plant grows. Everything else, you keep it exactly the same. That's the only way you can be sure that the one thing you changed is what actually caused the result. So you've collected all this awesome, precise data. You can't just let it sit in a notebook, right? You've got to organize it. And by putting those results into tables and graphs, we can literally see the story the data's trying to tell us. You start to spot trends, maybe a hidden pattern. This is the moment when all those raw numbers start to become real, actual insight. Okay, so let's see this whole toolkit in action. We're going to look at one of the most famous scientific investigations in all of history, one that completely, fundamentally changed how we see ourselves and our place in the universe. For more than 1,000 years, it was just accepted fact. The Earth was the center of everything. That was the geocentric model. But then a new theory started bubbling up, the heliocentric model, which put the sun at the center. I mean, what a radical idea. And it kicked off a huge scientific debate. And this case is just a perfect example of how science is supposed to work. The shift didn't happen because of a popularity contest or someone's opinion. It happened because of new evidence. New tools, like the telescope, allowed people to make observations that just didn't fit the old model. The old story just couldn't explain what people were now seeing with their own eyes. And that's the bottom line in science. When the evidence doesn't fit the model has to change, period. No matter how big of a deal that change might be.
This whole quest to understand the skies, it isn't new. And it definitely doesn't belong to any single culture. It's a deeply human thing, stretching back thousands and thousands of years. And it's still going on today as this massive, global, collaborative effort.
I mean, for tens of thousands of years, Aboriginal and Torres Strait Islander peoples have been expert observers of the universe. They developed these incredibly sophisticated systems of knowledge just by carefully watching the stars and the moon. They could predict seasons, understand the rhythm of the tides, track animal behavior. It's just a powerful, amazing example of science and practice long before we called it that. And that same spirit of observation is alive and well today, just on a global scale. Seriously, no scientist really works alone anymore. The big breakthroughs, they're almost always the result of teams collaborating, sharing their data, and building on what others have already discovered. You could say science is the ultimate team sport, played across generations. Which brings us right up to today, to the very edge of what we know. So where is our big cosmic investigation heading next? Well, just like the telescope completely changed the game for astronomy centuries ago, our tools today are sparking a whole new revolution. We are building these absolutely incredible instruments that let us see the universe in ways that, honestly, we could only dream about just a few decades ago. Just look at the James Webb Space Telescope. This thing isn't just a bigger telescope, it's basically a time machine. It can look back over 13.5 billion years into the past. It's capturing light from the very first stars and galaxies. I mean, every single image it sends back is a flood of new clues, challenging our old ideas and making us ask questions we never even thought to ask. We're watching the scientific process happen, right now, in real time. So from the patient, careful observations of ancient astronomers, all the way to the mind-blowing power of our newest tech, the basic process is still the same. You question, you investigate, and you analyze. The detective's toolkit keeps getting more and more powerful, for sure, but the curiosity that drives us, that's timeless. The only real question left is, what mystery are we going to solve next?